All right, good afternoon. Welcome back. Everybody missed. Oh no, I forgot to get water. Oh no. All right, got it under control. What's up, Caitlin? Okay, so reminder that if you haven't yet sent me your performance task, go ahead and do that by the end of the day. I've gotten several already, but still waiting on a handful of people. So yeah, just sometime before the end of the day. That'd be great. Tonight, whatever. Otherwise, we're going to go ahead and just move on to our next unit. We're on a really good pace right now. We do not have that much left. So we'll have plenty of time to go through this stuff pretty slowly. And even then, we'll then just kind of have a gap of time where you can kind of work on whatever you need to work on, whether it's PFAs or studying for the final, and then we'll have our final exam. I'm still waiting to hear I'm still waiting to hear from MCC about specifically what the final exam will look like, but we got a while and we have time, so no big worries. So let's go ahead. Start off. So we're talking about matrices. Right, a matrix. I've kind of already briefly mentioned a matrix whenever I talked about entering in, like using the TI-84 to solve a system of equations. And like we made our little kind of like box of numbers. Right, this was an example of a matrix, right? Or the function that we used in the calculator was the matrix button and all that stuff. So talked a little bit about matrices, so let's kind of formalize a little bit of stuff and just get through some basic properties today. Again, it'll be a quick, short lesson. So a matrix is a collection of values arranged in rows and columns. We write m by n, right? That's how we say it, m by n. So what this denotes is m is the number of rows that the matrix has, n is the number of columns. Okay, so for example, this matrix has 2 rows and 3 columns, so we would call this a 2 by 3 matrix. Right, so that's what we would call like the size or the dimensions of the matrix. It's a 2 by 3. Right, the rows is always the first number, columns is always the second number. Position of the values is denoted by this A, I, J. I, the first number, is again the row position. J is the column position. So this is how we'll talk about like a specific spot of a matrix. Right? Instead of, how do I describe where these numbers are? So if I don't want to just say like, oh, the middle number in the top row, right? It's kind of informal. It's not very efficient. Or if I didn't want to say like, the bottom right corner, we'll use this AIJ to do it. Right? So for example, here's a matrix. This matrix has 1, 2, 3 rows and 1, 2, 3, 4 columns. So I would call this a 3 by 4 matrix. And if I want to talk about a specific spot, let's say this 3. right? This 3. So how would I say where that is? Well, so I use my A. This is in the second row and the second column. So I would call this spot A22. Okay, or let's say I wanted to know what is in the A34 spot. Well, so I look at this first number is a 3, so that must mean the third row. The second number is a 4, the fourth column. So where do those two lines hit? 9. Right, let's do one more. Let's say A13. First number is a 1, so the first column. The second number is a 3, so the third column, or sorry, the first row and the third column. So that's the other 3. Well, one of the other 3s. All right, so for this notation and for this notation, the first number is the row, the second number is the column. Right? The rows go across, columns go vertical, up and down. Matrix addition and subtraction. The two matrices must be the same dimensions. They have to be exactly the same. Right? No differences. And we add or subtract values from the corresponding positions in each matrix. Okay, so the first thing before we start adding or subtracting any matrix together, we first have to check, are they the same dimensions? Right? Exactly. Are they both 2 by 4? Are they both 3 by 7 or whatever? But are they the same? All right, so starting off, I want to subtract these two matrices, but let's first do a check. So this first matrix, 3 rows, 2 columns, so it's a 3 by 2. This second matrix, 3 rows, 2 columns, also a 3 by 2. These are the same dimension, so yes, I can do subtraction. We can do the matrix subtraction here. And what does this equal? Well, it's very intuitive. It's kind of, I think, what you would guess if you had to try to guess what the rule is for matrix subtraction or matrix addition. Right, you just, tired. You just subtract the corresponding positions. So, for example, 3 minus 2, because those are both in that same position. So 3 minus 2 is 1. Right? Or negative 12 minus 1. That would be negative 13. Right? Or negative 5 minus 1. Negative 6. 4 minus 7. Negative 3. 2 minus negative 1. So that's 2 plus 1. That would be 3. And then 8 minus 8 would be 0. So we just match them up. Very intuitive, very straightforward. Okay, our next matrix operation is we can do what's called scalar multiplication. So this is multiplying a matrix by a constant, right? Or another word for a constant is a scalar. Take every value in the matrix. Maybe not. You could also try putting it in the matrix. There we go. Take every value in the matrix and multiply it by the scalar. My secretary must have screwed this up whenever they were making it. Terrible work. They'll be fired, rest assured. So again, scalar multiplication, also very intuitive. It's probably what we would guess would happen. Okay, so I have this matrix, just for practice. This is a 2 by 4 matrix. Oh, yeah. Right here. Or to the one before this. Look, this will be so smart. Perfect. You can't even tell the difference. Editing master. Okay, cool. Okay, so we have this 2 by 4 matrix. Scalar multiplication. This works with any dimension. Okay, for addition, subtraction, they have to be the exact same dimension, 3 by 2, 3 by 2. Scalar multiplication, it doesn't matter. You can do it with any matrix you want. Right, so we have 20 times this matrix, so we're just going to take everything and multiply it by 20. That's it. So 20 times 6, 120. 20 times 1, 20. Times 2, 40. Times negative 3, negative 60. Times 1, 20. Times 4, 80. Times 0, 0. Times 8, 160. That's it. Again, very simple, very intuitive. Can't get my neck to pop. Usually it does a lot better. Okay, find negative 5a plus 4b. All right, so I want to find this expression. I know what a is, I know what b is. So hold on, it wants me to add these together. So before I do that, I want to make sure that these are the same dimension. So 3 rows, 3 columns. That's a 3 by 3. 3 rows, 3 columns. This is also a 3 by 3. Okay, so it will work that we can add these matrices together, but that's only because these are the exact same dimension. If they were different dimension, I would just say like no solution, or cannot be done, or it's impossible, or something like that. Right. So let's first do negative 5a. So I'm going to take matrix A and use scalar multiplication of negative 5. So that just means I'm taking all of this stuff, multiplying by negative 5. So here we go. Negative 15, negative 10, negative 5, negative 5, negative 20, 0, negative 30, positive 25, 0. Okay, we're going to add that with 4b. Okay, so here's matrix B. Oh no. I'll just take matrix B, multiply everything by 4. 4 times 3 is 12. 4 times 0 is 0. 4 times negative 3, negative 12. 4 times negative 1, negative 4. 4 times 2 is 8. 4 times 5 is 20. 4 times negative 1 is negative 4. 4 times 4 is 16. 4 times 6, 24. Okay, and now I want to just add these together. So remember, just go spot by spot. Negative 15 plus 12, negative 3. Negative 10 plus 0, negative 10. Negative 5 plus negative 12, negative 17. Negative 5 plus negative 4, negative 9. Negative 20 plus 8, negative 12. 0 plus 20, 20. Negative 30 plus negative 34, negative 34. 25 plus 16, 41. 0 plus 24, 24. A little off the mark. And that is my final answer. So it was just scalar multiplication first. After that was done, add the matrices together. Okay. A couple special types of matrices that we'll talk about and that we'll use. So first off is called a square matrix, which means it's M by M. So there's the same amount of rows and columns. All right, so for example, all three of these are example of square matrices because they're all 3 by 3. Right, same amount of rows and columns. I don't know if we had any more. I think that was it. Oops. Okay, but another example would be even something simple like 1, 0, 2, 10. All right, that's a 2 by 2, which means it is a square matrix. But it could be any number. 10 by 10, 100 by 100, 57 by 57, whatever. As long as the same amount of rows and columns. We also have the identity matrix, which is a square matrix that has ones along the main diagonal and zeros everywhere else. So what does that look like? Well, it looks like this. Right? So ones along the main diagonal. You can see here we have all these ones right here. And everywhere else there is a 0. So all of these are 0, all of these are 0. It's only those ones that go along that diagonal that are the only things that aren't 0. we would call this I3. I for identity, and 3 meaning there's 3 rows and columns. Okay, but we could also see, let's say I2. So the 2 represents there'd be 2 rows, 2 columns. So I2, the identity matrix for row 2 or for 2 rows and 2 columns would look like this. 1's along the main diagonal, 0's everywhere else. Right, there's not a lot of spots in this one, but it still is the case. I'll do one more just because why not? Let's say I4. Right? 1's along the main diagonal. Everything else is a 0. All right, so this is what we call the identity matrix. And lastly, we have what's called the 0 matrix. This can be a matrix of any size, does not matter. All it means is all the matrices are 0, or all the entries are 0. Boom, 0 matrix. Or 0 matrix, okay? It's like 0. It's like the matrix version of a 0. Right, so adding or subtracting, whatever. But any size of matrix, as long as there's only zeros inside of it, called a 0 matrix. It's a very creative name. And I think that's all that I have for today. All right, told you it'd be short. Just a brief introduction to matrices. Because the next thing we're going to talk about is matrix multiplication. We talked about scalar multiplication, which is take a matrix and multiply it by a scalar. But what we're going to learn about next time, and which takes a little longer and some more steps, is what about if I want to multiply a matrix times another matrix? Okay, and it's not as intuitive as you would think. It's not just like with addition where we just like, oh, multiply this number with this number, this number with this number. Okay, it doesn't match up just like that. So that's what we'll talk about next time, and then we'll use it to get into some more complicated matrix stuff that will take longer, and it'll be a little stickier, a little more detailed, but it's good. Again, we'll probably have a handful of very short classes like this that don't do much. May I take a PFA? Absolutely not. Who do you think you are? Yeah, I just approved it. Yeah, you're both good to go. Good luck. And I will see you guys tomorrow. All right. Again, if you need to get me that performance task, please do. Please make sure your friends are doing so as well. Remind them. And I'll see you guys back tomorrow. Hope you have a great rest of your Thursday.